Let's do another quick demo following immediately after my previous one where I was showing how to configure a wildfly application to work with the Cryostat 4.0 operator auto-configuration feature for the Cryostat agent. What we're going to do next is show how to configure some of the other Cryostat agent features that go along with the usage of the Cryostat agent in this scenario where you're using the auto-configuration to get the agent into your application. So as a brief recap, what we've done so far in the previous demo is we basically just added these three labels to our deployment, our application deployment spec template metadata labels. We have these two here which together define which Cryostat instance we want this agent to register with. And then this one above is what we use to ensure that the agent is properly loaded by Wildfly. So that's how that works. What we're going to do is scale this thing up. Actually, I'm going to go ahead and edit the deployment first. So in the same place, I'm going to add another label, cryostat.io/harvester template, and I'll say default. The Agent Harvester is an agent feature where the agent will start a flight recording immediately. When the agent starts up, it'll start recording in the target JVM that it's attached to, and the name of the template we're going to use is default. So if you look within your JVM container image, you'll find that in some path like /user lib JVM Java 17 OpenJDK JFR, there will be usually two event template files. So there will be something named like this, default.jfc, which is JDK flight recorder configuration, or profiling.jfc. We don't need the sort of suffix, right, the .jfc here. We just use the name of the file without that. So we say default in this case. So let's save that, and what it's going to do again is tell the agent to start a recording using that template when it starts. And then I've shown this in a previous demo. When the application is exiting, the agent is going to capture that JFR data and upload it to Cryostat on exit. So if maybe your application is being scaled down manually, that may not be as interesting. But if something is happening, like your application stops responding to a liveness probe and Kubernetes or OpenShift decides to kill that replica and replace it, then maybe your agent is able to capture some flight recorder data and push that to your Cryostat instance, and then you can inspect the JFR data and hopefully find out why did your application stop responding to liveness probes. So if we scale that down, we can see that an archive recording was pushed to Cryostat, right? So that's the behavior. But what we may also find useful is that we would like to have that data pushed to Cryostat on an ongoing basis. Maybe we don't want that to only happen when the application is exiting. We might want to be able to capture that data periodically. So that's also a feature that the Cryostat agent supports. That is very similar to Cryostat's automated rules. So I'm not going to go into depth about this, but basically automated rules are done on Cryostat itself. You can set up a schedule and it'll start a recording and pull the data out of the applications into Cryostat storage on schedule. The Agent Harvester, when you set up periodically, it's done by push. So the agent on the application is the one that starts a timer, and on a scheduled period, it'll push that data into Cryostat. So very similar concepts, implemented a little bit differently, but they can be used for many of the same use cases. Automated rules are a much older feature than the agent is. So for a lot of users, actually, it's likely that using the Agent Harvester and the periodic configuration may actually be the preferred way to go. Okay, all that said, let's take a look at how to actually do this. So if we go back into our deployment here, into our same place with these labels, we've added this one label for the Harvester template. And there are some other labels that are supported by this auto configuration feature that you can do things to edit how the Harvester is going to behave, but not everything is supported. And there are other agent features such as smart triggers, which are not implemented in the auto configuration feature directly, but that's not to say they can't be used. So what will happen is you can actually sort of merge your configurations, and this will be picked up by the agent just as usual at runtime. As I showed in the previous demo, what actually happens in practice here is when you use these labels, the operator patches your pod and adds a whole bunch of environment variables, which is how it sort of communicates that configuration to the agent. The agent sees these environment variables at runtime when it starts, and that's how it picks it up. So for example, here we see the Cryostat Agent Harvester template default. This corresponds to the additional label that we set. So what that means is that we can manually edit our deployment and add more configuration options, which the labels don't directly support, but we can add them in anyway. And so for example, if we do that to this wildfly container here, I'm going to go ahead and add the env section for environment variables, and we're going to add one named like this, Cryostat Agent Harvester. So that follows the same sort of prefix that we just saw for the template. And I'm going to use one called period ms for milliseconds. And the value, I'm going to put it a pretty short period so we can see it happening frequently during the demo. I'll say 10,000, so that's 10 seconds. And I'm going to add another one here, Cryostat Agent Harvester max files. And I'll say 3. So what this means is that when the agent pushes a file to Cryostat, it'll say also, by the way, I only want you to keep 3 copies of the data that I'm pushing. And so Cryostat, when it receives the file, it'll check, okay, how many copies do I have from this agent? And if the agent pushing one now goes above that limit of 3 in this case, then Cryostat will delete the older files. So you'll push a 4th one in, and then it's like a queue, so the oldest one gets dropped. So you always have 3 copies of that data present in your archives. That's it. Like I said, there's a lot of other features for the agent that are not directly supported by these labels. They can be done like this with environment variables instead. So check your documentation, check the README for the Cryostat agent to get more information about what all of these other features are. They all will generally work like this. Just make sure you don't do anything that would be conflicting between the labels and the environment variables. Okay, so let's go ahead and save this. It doesn't like that these are numeric, I guess, so let's go ahead and make these strings. And we're good. Okay, so that's going to cause that to scale down and scale back up. So we see that happen on the other side here with our Cryostat view. And since I configured it to push data every 10 seconds, we should see one coming in pretty soon. So there's one. So let's watch what happens. So our first one just came in. We can see the push type is scheduled. And it can tell us also that we use the default template. It's a target type template. So we should see in just a moment here that another one should come in. There it is. Maybe I should have set that period a little bit shorter so this would happen more frequently for the demo. So just hang on, bear with me while, okay, third one comes in. And then 10 more seconds from now, we should see another one come in, and what's going to happen is the oldest one will get deleted. So it'll kind of roll over the data. There it is. So that happened, and then let's see what happens if we scale this thing down, right? No archive recordings, but let's go over to all archives. We'll see actually those are still present in the data here, right? So we can see that all of our same data that we just captured are still available. They're still in Cryostat's archives, and if we want to do anything to download this for analysis or view it in Grafana, all that functionality is still available, and so we were able to capture that data just like that. Okay, so that's it. Just to recap, the key takeaway was really just about how to add these environment variables to configure different agent features which are not supported by the labels. But again, key note, don't make conflicts. So what I mean by making conflicts would be if I were to do something like this, harvester template, and let's say I put the word profile in here, right? So then this environment variable is going to be a direct environment variable saying to use the profiling template whereas this label, the operator is going to want to set an environment variable using the default value instead. And actually, let's just see what happens, right? Let's take a look and see what actually ends up happening to our pod. We can see what happens in the case of a conflict. So the pod's been created. Let's take a look at it, see the environment. The template that won was the profiling template, right? So the profiling template, again, if we just go back and look at it to be certain, profiling won the fight. And the reason it won is not because of intrinsically that it's the profiling template, but the reason that it won is because this environment variable is already set, and so the operator is not overriding that configuration. Okay, that was it. Thanks for watching. Give it a try, let me know how it works, and have fun.